Okay, same process for division. I hope you've followed that by now. Let's try this one. We are going to start by proving P1. So we've got 4 times 7 to the 1 plus 3 times 5 to the 1 plus 5. We really hope that when we work this out, it's going to be divisible by 12. Otherwise, I guess our job here is done. So 4 sevens are 28 plus 15 plus 5. And that gives us beautiful 48, which is indeed divisible by 12. So 4 times 12. Therefore, P1 is true. Following the same old process, tried and true, we are going to assume that PK is true. So in other words, we are assuming that 4 times 7 to the k plus 3 times 5 to the k plus 5, we're going to assume that this will equal 12 times an integer. Okay, and we must say that A is indeed an integer. Now, we've used Z plus before. That indicates positive integers. We can also use N, which is for natural numbers, which is again the positive integers. So up to you which one you want to use. Okay, now we are going to hopefully use that to prove that PK plus 1 is true. Now, because we've done these a few times before, we know that sometimes we have to rearrange our PK, so I'm just going to leave an extra line. So to prove K plus 1 is true. So what are we trying to prove? We're trying to prove that 4 times 7 to the k plus 1 plus 3 times 5 to the k plus 1 plus 5. We want to end up doing some algebra stuff here, subbing in our pk to eventually show that this is going to be 12 times an integer. All right, so to do this, we've got a few options. Normally what we have done is split this up, so 7 to the k plus 1 would be 7 times 7 to the k, and then I can replace. But I think this is going to be a little bit easier if we replace the 5, okay? Because we can get that nicely out at the side there. So I can rearrange this to be 5 is 12a minus 4 times 7 to the k minus 3 times 5 to the k. Okay, so we're going to substitute this in. So this is going to equal 4 times 7 to the k plus 1 plus 3. And it's going to look a little bit ugly to begin with, but, okay, so here we go. We're going to replace that in here. So we've got 12a minus 4 times 7 to the k minus 3 times 5 to the k. So how are we meant to make that look a little bit nicer? Well, quite easily. We haven't got the same terms, although we can make them become similar terms, right? We can fiddle with these, and we can say that this is 4 times 7 to the k. Would you agree with me there? So again, 7 to the 1 times 7 to the k. When you're timesing by the same base, we get k plus 1, so that is the same. Okay, and then we're taking away 4 lots of 7 to the k. So basically, we've got 28 lots of 7 to the k minus 4 lots of 7 to the k, which will give me 24 lots of 7 to the k. And we're going to do the same thing now, right, with these. Okay, so this will now become 3 times 5 to the k minus 3 times 5 to the k, and don't forget our 12a at the end. Okay, now what have we got here? We've got 15 lots of minus 3, and what's that going to be? Lo and behold, 15 lots of 5 to the k, take 3 lots of 5 to the k is 12 lots of 5 to the k plus 12a, and I hope that you can now see that everything here, we can actually pull out a common factor of 12. So we've got 12 times 2 lots of 7 to the k plus 1 lot of 5 to the k plus a. Okay, and this, all of this is indeed an integer. So therefore, pk plus 1 is true, i.e. it is divisible by 12. Finish off with your statement. Okay, which you should know, and go and look it up if you have forgotten.